Hello, good morning or afternoon, depending on when you have class. Today we're going to talk about more about proportional relationships. So if you remember in class yesterday, we talked about how to check to see if a relationship is proportional. We thought about a proportional relationship, we graphed it, and we saw it. And what we ended up seeing yesterday, if you remember, was that a proportional relationship is going to start at 0, 0. And it's going to be a straight line on the graph. So proportional relationships, they start at the origin, or 0, 0, and they are a straight line. So that's a great thing to know if we have a situation, we're able to check if it's proportional, or if we're given a graph of a situation. But what about if we're given data in a different representation? So that's what today's lesson is going to be about. If you are in your notes packet, we're going to be starting on page number 7. If you're taking notes, I'll kind of point out what a couple of things that you want to definitely write down are as we kind of move forward. So identifying proportional relationships, that's going to be for today's topic, and it's not just if we're looking at graphs like we were doing yesterday. So in a proportion, we talked about this a little bit with going over the graph yesterday, if one quantity increases, the other is also going to increase. So for example, if I am buying potato chips that are on sale, 2 bags for $5, the more bags that I buy, the more money that I'm going to end up paying. What this creates then is what we call a K value, which is called the constant of proportionality. So the constant of proportionality is the unit rate in the situation, and we're going to actually start calling that K today. So what ends up happening is once we can figure out this unit rate or this K value, we can then actually write an equation in this format, y equals kx, where we'll actually be replacing K with a value, that K, that number that we end up getting. When I take a look at the first example, we actually have a table here. And before I even get into the table, one thing to recognize anytime you see a table is unless it's listed differently, the top is always going to be X and the bottom is always going to be Y. So that's kind of your first thing to know, all right? So what we are doing here is we have a scientist, we have a rover sent to the planet Mars, the time it took to travel several distances. You remember from this box up here that we just talked about, we're going to be figuring out K, our constant of proportionality, and that actually is a unit rate. So if I'm looking at this example, I have seconds and centimeters. We typically, when we're finding a unit rate, are going to say centimeters per second, which if you remember, created a division problem for us when we did a rate, and that would mean we would put centimeters on the top and seconds on the bottom. That allows us to realize that the constant of proportionality K is going to be found by taking one set of data points and doing the Y value divided by the X value, because that will give us our unit rate. So what I'm going to do here in the first example is I'm going to do 10 divided by 2. And 10 divided by 2 is going to give me 5. Now, there's something here that has to happen. If we have a proportional relationship, all K values will be the same. So that means if I have a table like this, guess what? I have to check every single K value for every single data point to make sure they're the same. This one's a pretty easy one to do. So 30 divided by 6, that's going to give me 5. 15 divided by 3, still 5. 45 divided by 9, still 5. And 20 divided by 4, sorry, wrote a 9 there, is still going to give me 5. So all of the K values for every data point in this table are all going to be 5. So that tells me that my K value here is 5. If you want to, we can put a label with it and we can say the K value is 5, and it really means that the unit rate is 5 centimeters per second. So the rate, and this should say rate here, tells you the meters per second, okay? Now, since we figured out that the K value is 5, remember we said that today we're going to be able to write an equation. So y equals kx is the format of our equation. We are going to actually fill in K with a value, because from our table, we did y divided by x to calculate the k value, the constant, and the k value was 5. So the equation for this line and for this relationship is actually y equals 5x. That's going to be important as you move into 8th grade with Algebra 1, but this is where we're starting for right now. Because all the k values were the same, this is a yes, it's a proportional relationship. And we can also know that if we were to graph this, it would be a line that goes through 0, 0, and it would be a straight line as well. Okay? Take a look at this second example. The number of bracelets that Reese can make in X hours is represented by the equation y equals 3/4 X. Complete the table of values below. So it says X hours, that would mean Y bracelets. So if I plug in 1 hour, X is 1, 3/4 times 1 is going to give me 3/4 of a bracelet, is what she can make in 1 hour. If I do 3/4 times 2, where X is 2 hours, I'm going to get 1.5. I'm going to just use a decimal here just so that I'm not using mixed numbers, because mixed numbers tend to get icky. If I do 3/4 times 3, that's going to give me 2.25, so let's put 2.25. And if I work for 4 hours, I'm going to end up making 3/4 times 4, or 3 whole bracelets. Now, because we were already given the equation here, we can actually figure out the k value. Remember, it's y equals kx. So k would be the number that's attached to the x, which in this case is 3/4. So our k value is going to be 3/4. Our ratio tells us the number of bracelets per hour that Reese is able to make. We don't need to really write the equation because it's already done, but it's y equals 3/4 x. And yes, this is proportional. If she works for 0 hours, she's going to make 0 bracelets. So it goes through 0, 0, and this would be a straight line on a graph. Take a look at the next example. So we have this diagram mapping values from one to another. So what I'm going to have you do is you're going to go ahead and pause the video, and there's going to be a series of 2 questions. The first question is going to ask you to calculate k. To do k, remember you're doing y divided by x, and you have to do that for every single value here. Y divided by x. So we're going to be going backwards here. 3 divided by 9, 4 divided by 12, and so on. So first thing you're going to do is calculate k. That'll be your first question to answer. And then the second question to answer is it a proportional relationship, yes or no? Coming back here, if I look, y divided by x, 3 divided by 9 is 1/3, 4 divided by 12 is 1/3, 5 divided by 15 is 1/3, 6 divided by 18 is 1/3, and 7 divided by 21 is also 1/3. So k is equal to 1/3, and since all the k values were the same, yes, this is a proportional relationship. In number 4, I'm going to ask you again to pause on this one, and I'm going to have you fill this one in. Remember, in a table, x would be on the top, y would be on the bottom. So your first task is going to be to figure out here what is your k value, and you do that by doing y divided by x. Now, remember, take a look at your label. The ratio is telling you the dollars per item. So when you get your k value, you need to round like you're working with money, which remember, money means you have dollars, and then there should be 2 numbers after the decimal point. So when you write your equation, it's also crucial for you to remember that your k value is going to still, it's not going to have the dollar sign on it, but it's still going to have the spot with the 2 decimal points afterward. So you'll pause it, you will choose what the equation is, and then again, after that, you will pick if it's proportional. So I went back here and I did $5 divided by 10, that gives me 50 cents. 10 divided by 20, that gives me 50 cents. 6 divided by 12, that gives me 50 cents. 8 divided by 16, that gives me 50 cents. And 4 divided by 8, that gives me 50 cents. So it looks like we're paying 50 cents per item. So my k value is going to be 0.50, which means when I go to write my equation, y equals kx, I would need to put 0.50 in here. because all the k values were exactly the same, that tells me right away that this relationship is in fact proportional. I'm going to show you real quick here with number 5. We're not going to spend way too much time on this one, but we have two different relationships. Relationship A says the value of y is equal to the sum of x plus 2. So that looks like x plus 2. So if I plug in just a couple values here, 0, 1, and 2 for x, and then I do 0 plus 2 is 0 plus 2, and that gives me a balance of 2 for the y. If I plug in 1, 1 plus 2 is going to give me 3. If I plug in 2, 2 plus 2 is going to give me 4. So looking at my ordered pairs here, I have 0, 2. I have the point 1, 3, and I have the point 2, 4. So remember, ordered pairs go x, comma, y. So when I'm finding my unit, my k value, my constant of proportionality, I'm going backwards. So my first problem is 2 divided by 0. If you remember, that causes a problem, and we call that undefined in math because you're not allowed to divide by 0. If I look at the k value here, I'm going to do 3 divided by 1, which will give me 3. So here we're calculating k in this column. And here, if I do k, I'm doing 4 divided by 2, which is going to give me 2. Notice how we got 3 different answers for k? That tells us that this is a big old not proportional relationship. Now, one of the things that you can realize is, remember this one, it said the value of y is equal to the sum of x plus 2. This tells me that this is what this equation would look like. Does that follow the y equals kx format? No, there's a number added to x, but not multiplied by x, which just further enforces that this relationship is not going to be proportional. If I look at relationship B, just take a look at this equation right here, 2x. So this tells me my equation is y equals 2x. I don't even have to put in values. I can tell you, yes, this one's proportional. And I can also, from this equation, tell you that the k value is going to be equal to 2, because remember, it's the form k times x. So my k value must be 2 here. So this is definitely a proportional relationship. Okay, tomorrow we're going to work a little bit more with proportional relationships, and we're going to look at, can we look at graphs now and actually identify the k value from a graph. So this is today's lesson for right now, is just taking a look at tables and taking a look at these ordered pairs like I demonstrated in this last example to see if we actually have proportional relationships, be able to find the value of k, and then also be able to write your equation.